take a look at the paragraph at the top of the paper. Please read along with me. Linear programming is a method used by businesses and the government to manage resources and time. It was developed in response to military supply problems in World War II. Constraints are conditions that limit available resources. These constraints are represented by inequalities. So if you look down below, all of your inequalities are your constraints. And for today, they will be set up for you. Next week, you're going to have to set them up yourself. Along with these inequalities, we have one equation called the objective quantity. The objective quantity is the equation that's down here. Most of the time it will have the letter P for profit or C for cost. And in your book tonight, it actually is going to say f of x comma y equals. And it's the same thing as either the P or the C value. The object of linear programming is to maximize or minimize the value of the objective quantity. Today we will go through the process of finding minimums and maximums. Once we understand this process, we will be able to apply the process to real-life problems. So for today and for tonight in your homework, you will be given the objective quantity and the constraints. Your goal is to graph all of them and find the shaded area, and then either maximize or minimize a profit or a cost. On Monday, we will be giving you problems where you're going to have to set up your objective quantity and your constraints. So to start for today, because these are real life problems, your axes are going to be over on the left and down on the bottom. Because if we're working in the real world, we're not going to have any negative values. So go ahead and draw your axes, your y-axis over on the left and your x-axis down on the bottom. And we will be graphing each of these inequalities that's highlighted in yellow. So if I want to graph the first one, x is greater than or equal to 1. That's the equation of a vertical line. So we draw a vertical line at 1. And because there's a greater than symbol, I want to shade to the right. So like yesterday, we'll go through and we'll put our arrows. The second inequality says that y is greater than or equal to 0. That is the x-axis. So go ahead and go over that darker. And again, because it says greater than, we're going to shade above the x-axis. And for the last inequality, you're going to have to solve for y. So subtract 3x from both sides and divide by 2. The y-intercept is 12. And the slope is negative 3/2, so you go down 3 and to the right 2. And a note to yourself, all of these lines are solid because they have equal to symbols in the inequality. There was a less than symbol, so we're going to shade below. And the region where all of the arrows are pointing to is that triangle in the middle. So go ahead and shade that triangle. In order to identify a maximum or minimum, you need to find all of the vertices of the shaded area. And vertices are just your corners. So there's one down here in the bottom left. The coordinate is 1, 0. There's one on the bottom right. That coordinate is 5, 6, 7, 8, 0. And the one up on top is a little bit harder to see because it doesn't intersect on the grid lines. We do know, however, that the x-coordinate is 1. And that point happens where the red line intersects the pink line. And the red line was the top inequality and the pink line is the bottom inequality. So if I took the number 1 and plugged it into the bottom inequality and solved, 3 times 1 is 3. divide by 2, half of 21 is 10.5. So that coordinate right there is 1 comma 10.5. In order to figure out your maximums and minimums, we go back to the objective quantity, that's the one highlighted in green, and we start plugging in these coordinates. So if I start at 1 comma 10.5, I'm going to plug in 1 for x and 10.5 for y. Take out your calculator, type them in, and it should give you 68. If we repeat that process for the coordinate 8 comma 0, I'm going to go back and plug in 8 for x, 0 for y. If you need a calculator, use your calculator. It should give you 40. And the last one, we go back and we plug in 1 comma 0, 1 for x, 0 for y. Again, if you need a calculator, use it. That one should give you 5. So in order to answer the question in your homework tonight, the minimum is going to be the smallest value. If I look at 68, 40, and 5, 5 is the smallest value, and it happens at 1 comma 0. For the maximum, I look at those three numbers again and I say the maximum is 68, and that happens at 1 comma 10.5. So we're going to repeat this process until you feel comfortable with it. If I go over to problem number 2, my objective quantity I will highlight in green, and my constraints are all of the inequalities. I know because this is a real world problem that my axis or my y-axis is going to go over on the left because I cannot have negative values, and my x-axis is going to go down on the bottom. If I were to graph the constraint x is greater than or equal to 0, that's actually going to be your y-axis, and it's already drawn there. So go ahead and put your arrows in. Greater than means you're going to shade to the right. If I look at the second constraint, y is greater than or equal to 0 is the x-axis down at the bottom. Greater than or equal to means I shade above. For the third inequality, you're going to have to solve for y. So subtract 2x from both sides. The y-intercept is 11, and the slope is negative 2, so down 2 and to the right 1. Again, all of these lines are going to be solid because they will have equal to symbols. And because it's a greater than symbol, I'm going to shade above the red line. For the second one, or I should say the last one, again you have to solve for y, so subtract x from both sides and divide by 4. The y-intercept is 4, and the slope is negative 1/4, so down 1 and to the right 4. It's a solid line because there's an equal to symbol. And because it's a greater than symbol, I'm going to shade above. Now be careful when you shade your region in here, because it will stop over on the left at the y-axis. When you get to the red line, it's going to stay to the right of the red line and above the blue line and above the x-axis. But this shaded area actually doesn't have a maximum because it's going to keep going up forever, and I can keep picking bigger numbers that are on the top of this graph anywhere I want. Because the region isn't enclosed on the top, I'm not going to have a maximum. So right away, I can say that my maximum I'm going to go find all of the intersection points. There's one over on the left. The coordinate is 11 comma 0. Sorry, 0 comma 11. There's one down in the bottom, kind of in the middle here. The coordinate is 4 comma 3. And there's one on the bottom right. The coordinate is 16 comma 0. If I take all of those points and I go back and plug into my objective quantity highlighted in green, I'm going to type into my calculator 7 times, let's start with 0, 11, so plug in 0 for x and 11 for y, and you'll get 11. If I go to 4 comma 3, I'll go back to that objective quantity, plug in 4 for x and 3 for y. If you need a calculator, go ahead and use it. It should give you 31. And for the last one, we're going to plug in 16 for x and 0 for y. Again, if you need a calculator, use it. It should give you 112. So if I compare all of those three numbers, the smallest one is 11, and that happens at the point 0 comma 11. Again, we don't have a maximum because I could pick any point that I want up at the top of the graph, but because it's not bounded, I could keep picking a bigger one, and I could make my objective quantity have a larger value. For the third problem, our constraint is the equation at the top. I'm sorry, our objective quantity is the equation at the top. Our constraints are all of the inequalities. So we go to our graph, and we put the axes over on the left and down on the bottom, because these are real-world problems. If I were to graph the first inequality, x is greater than or equal to 1, that is a vertical line at 1, and I would shade to the right because of the greater than inequality symbol. For the second inequality, it's a horizontal line. I go to 2 on the y-axis and I draw a line horizontally. And because it's a greater than symbol, I would shade above. For the last inequality, you're going to have to solve for y. So subtract the x to bring it to the other side. The y-intercept is 6. The slope is -1, so you go down 1 to the right 1. Draw in your line. Because it's a less than inequality, you're going to shade below the purple line. So the area that needs to be shaded is the little triangle that's in there. And I would go back and find all of the intersection points, or your vertices. The top left one is at 1 comma 5. The bottom left one is at 1 comma 2. And the bottom right one is at 4 comma 2. So you will go back to your objective quantity, the equation up at the top, plug in 1 for x, 5 for y. If you need a calculator, take it out, type it in, you should get 29. Do the same thing again for the second coordinate, plug in 1 for x, 2 for y, type it into your calculator or do the math, you should get 14. For the last one, plug in 4 for x, 2 for y, do the math, you should get 26. So in this case, our maximum is going to be 29, and that happens at the point 1 comma 5. minimum is going to be 14, and that happens at 1 comma 2. On the back of your worksheet, let's do it again. The objective quantity is at the top. The constraints are listed down below. They're the inequalities. When we go to graph, we put the y-axis over on the left and the x-axis on the bottom. The first constraint says x is greater than or equal to 2. That's a vertical line at 2. And if it's greater than or equal to, you shade to the right. For the second inequality, it says x is less than or equal to 5. That's a vertical line at 5. And less than means you shade to the left. So if I start looking for the final answer, my shaded region is going to be in between those two lines. For the fourth inequality, it says y is greater than or equal to 1. That's a horizontal line. Because it's greater than or equal to, I shade above. And looking ahead, I can tell that my shaded area is going to be in between the red and blue lines and above the purple line. And for the last one, y is less than or equal to 6. It's a horizontal line at 6. Less than or equal to means I shade below. So my final shaded region is the rectangle that's in between all of these because my arrows are pointing to that rectangle. I can go back and find the vertices. The top left one is at 2, 6. The bottom left one is at 2, 1. The bottom right one is at 5, 1. And the top right one is at 5, 6. I didn't give you an extra space there, so go ahead and just write it in. If I go back to my objective quantity, I plug in 2 for x and 6 for y. Go ahead and type it into your calculator. You should get 30. For the second one, I plug in 2 again for x, 1 for y. That should give you 10. For the third one, I plug in 5 for x, 1 for y. Will give you 19. And for the last one, I plug in 5 for x, 6 for y, and you should get 39. If I compare all of those numbers, the maximum is 39, and it happens at 5, 6. And the minimum is 10. It happens at 2, 1. Last problem. One more time, my objective quantity is the equation at the top. My constraints are all of the inequalities. I'm going to go over and put my y-axis on the left, my x-axis down at the bottom. When I graph x is greater than or equal to 0, that's actually the y-axis. Greater than or equal to means I shade to the right. When you graph the second inequality, y is greater than or equal to 0, that's the x-axis. It's already drawn in. Greater than means I shade above. I go to the third inequality and I have to solve for y. So I subtract 4x from both sides. y-intercept is 8. The slope is negative 4/3, so I go down 4 and to the right 3. And if it's a greater than symbol, I shade above. For the last inequality, I also have to solve for y. So I subtract x from both sides and divide by 3. The y-intercept is 5. The slope is negative 1/3, so I go down 1 and to the right 3. And because it's a greater than inequality, I shade above. So the area that I need shaded starts over on the y-axis, doesn't go to the left of it, comes down, stays above the red line and above the blue line and above the x-axis. And is everything in between. Now looking at the shaded region, one more time, I don't have any boundaries up on the top of it. So because I can keep picking larger and larger values for my x and y coordinates, there actually is not a maximum. I have to go back and find my vertices, and vertices are your corners, or if it's easier for you, where the lines intersect. I have one on the top left over here. That coordinate is 0, 8. I have one somewhat in the middle right here. The vertex or the coordinate is 3, 4. If I follow that blue line down to where it intersects the x-axis, I have one more vertex at 15, 0. So I go back to my objective quantity, and I'll plug in 0 for x and 8 for y. Use your graphing calculator. You should get 56. You do the last one, I plug in, the middle one, 3 for x, 4 for y. Use your calculator, you get 46. And the last one, plug in 15 for x, 0 for y, and you should get 90. So if I still have to fill in my minimum, the minimum is 46, and it happens at 3, 4. Now, just so you know, the problems that you'll do tonight in your homework, your objective quantity isn't actually going to say C equals or P equals. We'll come back to that on Monday. Your book uses the notation f of x comma y equals, and it gives you the equation. Don't be intimidated by that. It means the same thing. You just have to plug in your coordinates and get a value. And the second thing for your homework over the weekend is that because you're not actually dealing with word problems, your book might have some problems in the homework that actually do go to the left of the y-axis and do go below the x-axis. So you're actually going to have to graph the entire line and find out where the shaded area is. Do not stop at the y or the x-axis unless you have the constraints x is greater than or equal to 0, y is greater than or equal to 0. We're going to come back to that on Monday when I actually give you word problems. We are going to add those two back in. But for your homework over the weekend, do not assume that it stops at the x-axis or the y-axis. They can go to the left or below of those two. Your homework over the weekend is to do page 163, numbers 1 through 3, and 6. Keep in mind one more time that that shaded region does not have to be bounded by the x and the y-axis. You may have some shaded areas that do go outside of that boundary because we're not putting words to these yet and actually doing the linear programming problems.